All right, so welcome to Lecture 7, Part C, the last part of this series. So in this one, we're going to look at something called atomic notation, which is basically a way of representing what the heck is inside of an atom. So with that, let's go ahead and get started. All right, so let's start with a quick review about the atom, right? Last video, we learned there's three parts to an atom. Part number one is the proton. The proton has a positive charge. The proton lives in the nucleus. Also in the nucleus is the neutrons. Neutrons have no charge, and they are in the nucleus. And then the last particle that's part of an atom is the electron, which is outside of the nucleus, and it has a negative charge. All right, so with that, let's go ahead and let's get into a little bit more detail about these particles. And specifically, we're going to look at how can we figure out how many there are in an atom. So the way we can do that is actually a lot of it's going to have to do with our periodic table. So if you don't have a periodic table handy, I would print one out if you can, or I'm going to show you one on the screen, but it's going to be a little tiny, so I hope you can read it. But if you have a copy of the periodic table, I would go grab it because we're going to look at it for pretty much the rest of this video. All right, so when we want to talk about how many of these particles, protons, electrons, and neutrons, are in an atom, we use two terms. Term number one, atomic number. Atomic number, by the way, has a symbol. The symbol is the letter Z, so Z stands for atomic number. And atomic number is the number of protons in an atom. It's the number of protons in an atom. Now, let me tell you a couple other things about that, which is it's on the periodic table. You'll see it. I'm going to show you where in just a minute. It's on the periodic table. And let me tell you one more fact. It determines the kind of atom you are, the kind of atom. All right, so the atomic number, the number of protons in an atom. It's on the periodic table. It determines the kind of atom. All right, so if we look at the periodic table, the number I'm really referring to is the one you see above the symbol. So the number above the symbol, you know, where it says like, let me highlight a little bit, 1 and 2 and 3 and 4, those aren't just for counting. Those are telling you the number of protons. So the way it works is if we look at, let's say, for example, carbon, I see 6 there. Any carbon atom anywhere in the universe, it doesn't matter where it is, any carbon atom anywhere in the universe will have 6 protons. Any aluminum atom anywhere in the universe, I don't care where you are, you've got 13 protons. Any magnesium atom anywhere in the universe, you're going to have 12 protons. Now, we could also think of it the other way. If I said, I find an atom and it has, I don't know, 10 protons, what kind of atom is it? Well, if you got 10 protons, you're a neon atom. You're a neon atom. Or if I say, hey, there's an atom I found and it's got 20 protons. What kind of atom is it? It's a calcium atom. It's a calcium atom right there. All right, so the number of protons is on the periodic table and it goes with the symbol. If you got 26 protons, you're an iron atom. All right, now there's one other term that comes up, and that other term is called mass number. Again, there's a symbol. Mass number, the symbol for mass number is the letter A, the letter A. All right, now what is that? Well, again, it actually is telling us about how many of these particles we have. Now, to be exact, it's the number of protons plus the number of neutrons. It's the total of those two. Number of protons and the number of neutrons together. All right, so another way of saying that is that it's really the total of all of the all the particles in the nucleus, okay? So it's the protons and neutrons together. Now, one last fact I don't want you to know because this messes people up all the time. A mass number, it is not on the periodic table. There is another number on the periodic table. I am well aware of that fact. There is a number right underneath this symbol. That is not the mass number. What is it? Well, I'm not going to tell you. We're going to learn eventually, but I don't want you to get worried about that number yet. For right now, just ignore that number. Pretend like that number isn't even there, okay? The number underneath the symbol, you're not going to use it until about 2 more chapters. You're not going to know what it means for another chapter or so. So we're not going to worry about what that number means. Now, we'll talk about it eventually, but not in this lecture, okay? So that number, don't even think about it. It is nothing for you. It's like a bad ex-boyfriend or an ex-girlfriend or something. Ignore it. Don't even worry about that number, okay? So the mass number, I am going to tell you or give you mass numbers, but you will not find them on the periodic table. So the way that I'm going to tell you mass numbers is typically we're going to use a symbol. And let me show you an example of that. So the symbol we often use to kind of represent what's going on inside of an atom, what do we have inside of an atom? That's usually called atomic notation. And that's going to tell you about all of this stuff that we've been talking about. All right, so atomic notation, it's going to look something like this. I might write down or tell you this. Oh, I got to grab a different color here. Let's go with, I don't know. I like blue, actually. We'll go back to blue. All right. I might write this down. And actually, I'm sorry. Give me 1 second. Let me move this over a little bit. Yeah, that'll work better. All right. I might write down this 4120 Ca. 20 Ca. So that's a way of telling you all about this particular atom. Now, all the stuff is standardized. All this stuff is always in the same spot. So first thing you're going to see is that you're going to see the symbol of the atom. So in this case, the symbol is Ca. So the symbol is always on the right-hand side. So in this particular example, I'm thinking about Ca. I am thinking about a calcium atom. That's what Ca stands for after all, right? Now, the numbers. What are those numbers and what do they mean? Well, the number in the bottom corner, that is your atomic number. That's your atomic number. Another way of saying that is, that's the number of protons. The number of protons. Now, again, that should make sense because it's what we see on the periodic table. If we find element number 20 right there, element number 20 is calcium. So calcium always has 20 protons. So yeah, they should go together. If we're talking about Ca, you should have atomic number 20, and that's what I see. All right. Now, what about that top number? That top number, oh, that's the one that we also just mentioned. That's called the mass number. So that's where you're going to find it. You're not going to find it on the periodic table. You're going to find it when somebody writes something like this. Now, again, that mass number is your protons and your neutrons together. Your protons and your neutrons together. So when you look at this symbol, you should be able to use it and tell me all about this atom. So you should be able to tell me, hey man, he's showing me a calcium atom. The symbol tells me that. And you should also be able to tell me what's inside of this calcium atom. So inside of this calcium atom, the number in the bottom corner here, that's your protons. So this thing has got 20 protons. And if I asked you how many neutrons, well, how would you find that? Well, the way you would find that, if this is protons, and this is protons and neutrons together, if I want just the number of neutrons, what I would do is I would subtract. Protons and neutrons, subtract off the protons, whatever's left. If I subtract those two numbers, in other words, that's my neutrons. I'd have 21 neutrons, okay? All right, so let's do another example or so, okay? So this symbol is telling you all about this atom. Let me show you one more. So one more. So let's go over here and I'll write another one up. I guess we'll stay with blue, huh? So this guy right here, P3215. What is that? What kind of atom is that and what's inside of it? Well, first off, we're talking about a P atom. What does P stand for? It's phosphorus. P stands for phosphorus. All right, so we're thinking about a phosphorus atom. The number in the bottom corner, that is your atomic number. So this number right here again represents your protons. This fella's got 15 protons. Oh, again, yeah, that matches with the periodic table. They should go together. So yeah, 15 protons is element 15. It's phosphorus. Now, maybe we should jot this down. So we got 15 protons, I should say. Now, what if I wanted to know the number of neutrons? Well, remember again, this top number is your protons and your neutrons together. That's called the mass number. So if I wanted to know the number of neutrons, I would subtract 32 minus 15. This fella has, let's see, I guess 17 neutrons. So you subtract to get the number of neutrons. Now, a couple things I'll tell you. I haven't said anything about electrons. I'm going to bring up electrons in a future class. So for right now, we're just going to worry about the protons and neutrons. We're going to hear about electrons soon. We'll talk about the number of electrons. We'll get to that before you even know it. All right. All right. But for right now, let's just focus in on the protons and the neutrons. All right. Couple other things I want to mention. I've given you two atoms on this slide. So one way I could talk about them and try to tell you, hey, I'm thinking about this atom, is I could write that symbol. This symbol, again, is called atomic notation, where I give you the symbol off the periodic table, and then I give you the atomic number, and I give you the mass number. Now, the other way that I could talk about this atom is there's really two ways. I could, if I wanted to call it something, I would call this one on the right here. This would be called the phosphorus 32 atom, the phosphorus 32 atom. So the way that works is you write the name, and then you write dash, and then what number's after that? Oh, that's the mass number, the protons and neutrons number, the top number. Okay. You might even see it abbreviated, something like this. You might see P-32. That would be another way of talking about that atom. All right, so that's another way to represent it. I could give you the symbol, the atomic notation, in other words, I should say, or I could write phosphorus 32. That would be another way of talking about that atom. Or if I got a little lazier, I could write P-32. All right, so with that, let's do a little bit more on atomic notation. So making sure we can figure out, if you got an atom, can you tell me the atomic notation for it? What is it going to look like? All right, so let's do a few more examples having to do with atomic notation. Let me move on to the next slide. Okay, so what I want to practice a little bit is just writing out this atomic notation where you see the two numbers and the symbol. So that's shorthand to describe an atom. Tell me all about what's in an atom, protons and neutrons and the symbol and all that. Now, I'm going to do a few where I'm going to give you different information, but all the information you need to write out atomic notation, you're going to have it. But the way you think about it and the way you use it, it could be a little different depending on what I give you, okay? So, and we're going to do a few examples of this where I want you to write out the atomic notation based on some things I'm telling you. So atomic notation, that's what you saw a minute ago. Blankety blank blank. That's atomic notation. Just to remind you, over here, we put the symbol off the periodic table. Here, we're going to put a couple of numbers, all right? Those numbers we saw a minute ago. All right, so let's get to our example. I want you to write what it would look like, the atomic notation for a carbon atom that has 7 neutrons. A carbon atom with 7 neutrons. All right, so it doesn't matter necessarily where you start. You might have to, again, think it through a little differently depending on what I tell you. But let's just start with what I gave you first, a carbon atom. If it is a carbon atom, I am telling you it's carbon. You should know the symbol for carbon. What is the symbol for carbon? It is C. It goes right here. It is C. All right. I am, oh, by the way, if I tell you that it's carbon, you actually know one of the numbers over here. Remember the way it works is if you are a carbon atom, you have that 6 there. You have 6 protons. Carbon atoms always have 6. So the number in the bottom corner should be 6. This should be a 6 here. Remember, this is your proton number. So if you're carbon, that number's got to be 6. Carbons always have 6 protons. Another way of saying that is you have an atomic number of 6. Remember, that's the bottom number. Now, we're getting pretty close, huh? We only got to fill in one more blank. That top blank we put in one more number. That's the mass number, remember? That goes up here. Now, is the mass number, let's see, a carbon atom with 7 neutrons. So am I going to be writing 7 in that top corner? No, I shouldn't be writing 7 because the mass number, to remind you, is the protons and the neutrons together. We figured out, based on the periodic table, this fella has 6 protons. And I told you, you wouldn't know this unless I told you. I told you he's got 7 neutrons. So I want to write the total in that corner. It should be 13. All right, so this would be that. Now, again, another way I could represent this, just to get a little extra practice, this would be called, another way of representing this, I could call this the carbon 13 atom, carbon 13. All right, and that would be its atomic notation. All right, let's try one more. Let's try one more. So, you know, you got to be a little careful. There's a lot of things going on. You got to get it straight in your head, all right? It takes a little thinking, a little practice to get good at this, all right? So let's try one more. Atomic notation for a neon atom with a mass number of 23. Atomic notation for a neon atom with a mass number of 23. All right, what is that going to look like? Well, it's going to look something like this. Atomic notation is always blankety blank blank. All right, blankety blank blank. All right, so as far as that goes, let's start filling in those blanks. Let's read the sentence. A neon atom with a mass number of 23. A neon atom. Oh, you got to know those symbols, right? A neon atom. What's the symbol for neon? What's the symbol for neon? It should be Ne. All right, Ne is neon, so that goes right there. There's going to be some numbers. Now, if you know the symbol, I promise you always know this number because they go together. Neon, he's always got 10 protons. If you know your neon, you know this number. It should be 10. So that number goes with the symbol. If you know one, you know the other one. So neon is going to have 10 protons. See on the periodic table, it's element number 10. Another way of saying that is, yeah, that's the atomic number. Now, we still got to fill in the top, don't we? Top blank. Top blank. Now, be careful. I tell you something different this time. A neon atom with a mass number of 23. If I say mass number, that is the protons and neutrons together. That is the number that belongs in the top corner. So last time we had to do a little work, but not this time. If I say mass number, so you got to watch what I tell you, right? Though you got to watch, make sure you read carefully what I tell you. If I say mass number, you just write it down. It's 23. You don't need to do any work, all right? So again, that's your protons and your neutrons total up. Protons and neutrons. The mass number goes on the top corner. All right, what else could we call this thing besides 2310 Ne? You could call this thing the neon 23 atom, neon 23 atom. All right, so that would be another way of saying it. Or you want to get even fancier, you just write Ne-23. Okay, so it could be a little confusing because I might give you different information and I want you to write atomic notation for these things. So let me go ahead and let's do a couple more just to make sure, because man, can it be confusing. All right, let's try a couple more just to make sure we got this. Let's do a few more examples. So goal for all these, again, write the atomic notation. Write the atomic notation for a few more atoms, all right? So that's the 2 numbers and then the symbol off the periodic table. So again, you gotta be a little careful because I'm gonna give you different stuff and you gotta know what to do with that information to turn it into your atomic notation. All right, so 3 numbers, or 2 numbers and some symbols, I should say. 3 blanks to fill in. Blank, blank, blank. Let's get going. An atom with 11 protons and 13 neutrons, all right? So an atom with 11 protons and 13 neutrons. So I got to fill in all those blanks. Let's just start in the beginning. An atom with 11 protons. Where would 11 go? It is going to be one of those blanks. Does the 11 go in the top blank? Or does the 11 go in the bottom blank? Where would you put the 11? Top blank or bottom blank? The number of protons belongs in the bottom blank. So 11 goes down here. Remember, this is your protons, also known as the atomic number. All right. Now, oh, wait a minute. If we know it's number 11, you know the symbol because they always go together. So if you know that this is element number 11, if you got 11 protons, we are thinking about a sodium atom. This is also Na is going to go right here. So again, those two go together. If I tell you protons, you know the symbol. You got to know the symbol. 11 protons, that's got to be sodium. So we're almost set here. We only got to do one more step. We got to figure out the top number. The number in the top corner. Now the number in the top corner, is that going to be 13? Be careful. Is that 13? What is that top number again? That's protons and neutrons combined, also known as the mass number. So it is not 13. You've got to get the total protons and neutrons. It should be 24. It should be 24. All right, so again, you got to be careful when you figure this out. It can be a little tricky. I'm going to give you different stuff. You got to know what to do with it. If I tell you protons and neutrons and I want the top number, the mass number, you got to add them together. All right, let's try a couple more. All right, another one here. Number D, an atom with a mass number of 17 and 8 neutrons. An atom with a mass number of 17 and 8 neutrons. Blankety blank blank. Fill in all those blanks. A mass number of 17. Oh, mass number, that's one of the blanks. Which blank is it? The top blank or the bottom blank? It belongs on the top blank. So you would put the mass number would be 17. That's what's up here. That's your protons and your neutrons. That's also called the mass number, right? All right. And then I say 8 neutrons. Mass number 17, 8 neutrons. Now, what goes in the bottom blank again? It's not the number of neutrons, right? The number in the bottom blank is your number of protons. So please don't write 8 down there. The bottom blank is not the number of neutrons. What should go in the bottom blank? It should not be 8. It should be, what number belongs in the bottom blank? It should be, we got to do a little scratch work here. 17 minus 8, 9. This should be 9 here. Because we know the two together, the protons and the neutrons add up to 17. All right, the protons and the neutrons add up to 17. That's what the mass number is. So if I tell you 8 out of the 17 are neutrons, the other ones are your protons. And that's what you write down. You write down in the bottom corner the protons. Okay, one more blank to fill in. And that is the symbol. Wait a minute. Oh, we know that. If you're element number 9, look at your periodic table. We're looking about fluorine. This is fluorine. All right. So it can be a little confusing because you got to know what to do with all these numbers. You got to know, do I need to just write them down and in which blank, or do I got to do a little work to get the numbers I'm supposed to be putting in those blanks, right? It can be a little confusing. All right, let's try one last one. Let's try one last one. All right, an iron atom with 30 neutrons. An iron atom with 30 neutrons. Blankety blank blank. So, an iron atom. Let's just start at the first thing I tell you. An iron atom. Oh, wait a minute. I know the symbol, don't I? What's the symbol for iron? The symbol for iron is Fe, and it belongs right here. It belongs right here. All right. Oh, wait a minute. If I know it's Fe, I know this number. Fe is element number 26. So you got to put 26 here. Okay. Now, wait a minute. We need not one number in the top, don't we? All right. So what number would go on top? Are you going to write 30 here? Are we going to write 30 here? 30. Is that what goes up there? No, it's not what goes up there. So if this is your protons, I know that because we're talking about element 26, iron. The number on the top is your protons and your neutrons. So if it's protons and the neutrons together, and I tell you, you figured out 26 of them are protons, and I tell you, you wouldn't know any other way that there's also 30 neutrons, I put the total there. The total, it should be 56. All right, that's what it should look like. All right, one last thing. What would you call this thing? You could write that symbol and oh man, I know all about that atom now because you're with that symbol. But what else could you call it? You would also call it, you could call it iron and then dash 56. That would be another way to name it, iron dash 56. Or you could even write Fe dash 56. All right, so I have to say, this is one of these topics where, it takes a little while to sink in, I think, for a lot of people, for it to kind of really make sense to you. So practice is going to help you, right? Chemistry is not watching some dude do it for you. It's practicing. And then the other thing, you got these videos. There's no saying you can't watch it again if you're like, I didn't quite get it, or I'd like to see that explained again for it to really make sense to me because there's so many numbers and so many terms I never heard of. Right, so this is one of these topics where I'd be, not at all surprised if you need to watch this video a couple times for it to really make sense. All right, so no harm in doing that. All right, there is actually one last thing I want to mention, and then I need to move on to the last slide to do that. Okay, one more thing with these symbols. Okay, so let's go on to our last slide. All right, so one last little thing I want to show you. So let me write out a few more symbols for some atoms, atomic notations, I guess I should say. So you might see this, 12, 6C. You might see 13, 6C. You might see 14, 6C. Now, all those look pretty darn similar, don't they? And they are similar. Like, if you look, they're all the same kind of atom. All atoms of the same element. Now, in this case, they're all carbon atoms. So all three of those represent carbon, but they're not 100% the same, right? Because how are they different? Well, the number in the top corner is different. So they have different mass numbers. They have different mass numbers. So the top number is different. One of them has a mass number of 12. One of them has a mass number of 13. And the last one has a mass number of 14. So they have different mass numbers. Now, another way of saying that is there's a particle that's different about them. So what is different as far as one of those three particles we've been talking about, protons, neutrons, or electrons? It's the number of neutrons. So the number of neutrons is different. Like the way I get the number of neutrons is you subtract, right? So 6 minus 6, this fella has 6 neutrons. 13 minus 6, this fella has 7 neutrons. And the fella on the end has 8 neutrons. So if you subtract, you'll see that what really makes them different is that they have a different number of neutrons. Have a different number of neutrons. And what I mean by that is like compared to each other, neutrons. They have a different number of neutrons compared to each other. So there's a word for this. There's a term for this. You're the same kind of atom. You're all carbon atoms, but you have different neutrons compared to your neighbor, compared to your friend. And that is, these guys are called isotopes. They are isotopes. So isotopes is just a word for, we'll say, different forms of the same element. Different forms of the same element. There we go. All right. So they're all carbon atoms, but they have a different number of neutrons. So we could say there are, and this is actually all the types of carbon that exist, there's 3 kinds of carbon atoms. There are 3 forms of carbon. These are the 3 isotopes of carbon. That would be a way of explaining how these guys relate to each other. Okay, they're the 3 isotopes of carbon. So most elements come with more than one variety. And the way that they're different is they might have different number of neutrons compared to another atom. All right, so just to be 100% clear, like I could write out these symbols and then Oh yeah, right. We can also write out the words. This guy right here would be called carbon 12. This guy in the middle is carbon 13. And then the fell on the end, this guy would be called carbon 14. So that would be another way of telling them apart. All right, so with that, I think that's it for atomic notation. And of course, if you have any questions, it can be a little confusing, so we'll get a little practice at some point. We'll do some homework on it, and we'll do some stuff in Zoom to help you out too. And then, of course, you can email me or call me if you have a question or a concern about this. All right, that's it for this one. I'll see you next time.